Okay, a 10-meter board, right? What speed will you go when you hit the water? So I'm picturing this. Right, here's our 10-meter board, side of the pool, water, right? 10 meters means that it's 10 meters down, right? Okay, so the displacement will be, we'll say that it's just 10 meters. That's our distance, right? There's no mention about an initial velocity, so I'm going to say it's 0. That is, we just step off that board and just, whoa, 10 meters, that's a long way. That's 32.81 feet. That is a tall, tall board. So if you just jump off that, it's pretty terrifying. And then the acceleration is going to be the acceleration of gravity. So it's going to be 9.8 meters per second squared. And we're going to make the down direction positive. So we're not going to do that in general, but let's do it here. Okay, so what time will it take you? Okay, so to do that, to find time, we would use no VF, right? So let's try that. Let's see, X is VIT plus 1/2 AT squared. That's our formula, right? So 10 is 0 times time, which we don't know, right? Right, plus 1/2. A is 9.8 times t squared, right? Now, luckily, this term just goes away. 0 times t is, there's no t left, right? So we end up with 10 equals 1/2 9.8 t squared, right? Now, to solve this, we got to get rid of the 1/2. So let's multiply both sides by 2, right? Multiply this by 2. Well, when you do that, the 1/2 goes away and the 2 goes away, right? And then divide both sides by 9.8. Right, when you do that, this goes away. And now you've got 2 times 10 over 9.8, right? And that's t squared. And now the question is, how do you get t? Well, you take the square root of both sides, right? So the square root of 2 times 10 over 9.8, okay? So when I do my calculator, I've got an old calculator, I'll go second square root, and then I have to type the left parenthesis. And I go 2 times 10 divided by 9.8, right parenthesis, and it says my time is 1.4254287 seconds. It just keeps going. Okay. Now we've got about 3 digits there, so we would round our answer to about 3 digits like that. And now you want to figure out the final velocity, right, that they have. It's like, oh, I've used up all the space. Well, let's carefully grab a chunk of space here. To find the final velocity, I would use no t. Now you could just use, basically it's going to be 9.8 times that, right? So I could do, VF is VI plus AT, right? 0 plus 9.8 times 1.42857, right? So if I did that, I would get 14 meters per second. It comes out even. This is like freaky, right? Okay. That's one way to do it. However, what if that's wrong? Okay, what if we got the wrong answer there, right? There should be a way to find the final velocity without using t, and of course there is, right? Use this guy. VF squared is VI squared plus 2AX. Okay, so VF squared equals 0 squared plus 2 times 9.8 times 10. Okay, so let's see. That's VF, so let's square root it, right? So VF will be the square root of 2 times 9.8 times 10. Well, 2 times 9.8 times 10 must be 14 squared times 10, right? It's 196, right? And the square root of 196 raised to the 0.5 is 14. Ta-da. That's the way to do it. Okay. Now, technically speaking, since we took the square root of a square here, we actually are, this is actually could be positive or negative 14. In this case, the negative doesn't make any sense, so we just say it's 14. Right, so this final velocity is 14 meters per second. It's final speed, right?